Hi folks, we're now going to take a look at factoring trinomials where the leading coefficient is not equal to 1. So in other words, we're going to take a look at trinomials of the form ax squared plus bx plus c, where a is not equal to 1. Okay. Now this is a little more complicated than factoring those where the leading coefficient is 1. But I'm going to do similar to what I did last time, is work backwards. I'm going to start with the most general factored form for this scenario. So I'll say mx plus p times nx plus q. So here, one thing to keep in mind is any time the coefficient in front of the x squared is not equal to 1, there's no way it can factor to have both x and x starting off the two binomials. You'll need to have a coefficient other than 1 in at least one of them. So let's multiply this out and see what happens, see if we can find some patterns. So multiply the first two here, so we have mnx squared, then we have mqx, then we'll multiply these two here. I'll write it in alphabetical order, write it as npx, and then the last plus pq. Okay. Now we'll bring together the like terms, which again as usual are the middle terms, and since when we add like terms we're only adding the coefficients, so I'll write it as mq plus np, all of this times x, and then plus pq. Okay, so if we're to have a quadratic polynomial factoring into the product of two binomials, we need our a value to be a product of the two coefficients of x, and we need our c value to be the product of the two constant terms. Okay? And then this b value will be a combination of all four. In fact, it's going to be the outside coefficients added to the product of the inside coefficients. Okay? I think the best way to do this is to actually look at an example. Now we're going to see two ways in which we can factor these. One of them is trial and error, and you may be surprised, but that's actually the way I'm going to suggest people try to learn how to factor these trinomials. While there is a more algorithmic way of doing it, it's much longer, and if you can learn how to do it this way by trial and error, it'll serve you well in the future. So we'll take a look at the example 2x squared minus 5x minus 3. Now I chose this one because it's actually an easier example, because when we think about the coefficient of x squared, okay, we need to find two numbers that multiply to 2, and there's only two such numbers, 2 and 1. So we know that we're going to have a 2x, and we'll have to have a 1x, or just x, okay? And 3 only has two factors, 1 and 3. The question is, where do we put the 1? Where do we put the 3? Because that will make a difference. So this is what I'd like you to try doing, is set up two columns. Your first column will be your coefficients of x. In this case here, we know they have to be 2 and 1. And here, we're going to have our constant coefficients. Okay, so we know it's going to have to be 3 and 1. The one thing we don't know is in what order we're going to place it. So if we place 1 and 3, we'll be multiplying the 2 by 3, the 1 by 1. Or 3 and 1, 2 by 1, 1 by 3. So the way in which I represent this is I could have this combination of multiplications, or I could have this combination of multiplications. So let's start with this cross one. So I've got 2 times 1 is 2, 1 times 3 is 3. So I've got 2 and 3. And now we have to look at this middle term. Now that might actually look good because you say, oh, 2 and 3, 5. But let's keep in mind that one of these, okay, either the 1 or the 3 here is going to have to be negative. So in this case here, one of these will have to be negative. If the 2 is negative, negative 2, positive 3, that won't work to get us negative 5. If the 3 is negative, negative 3, positive 2, still won't work to get us the negative 5. So that means we'll have to try the other combination. So let's try 2 times 3, okay, which is going to give us 6, and then 1 times 1, which is going to give us 1. And is there a way to combine these two, knowing one of them will have to be negative in order to give us negative 5? And that's when we realize that negative 6 plus 1 is equal to negative 5. Okay, so that means the 2 is going to have to multiply the 3. So that means I have to put the 3 in this position. And in order for the 1 to multiply the 1 is going to go in that position. And we need the 6 to be negative. So we'll put that there, and the other one to be positive. And there we go. We've just factored this trinomial. Let's check quickly that it does indeed give us the correct factorization. So 2x times x, 2x squared, negative 6x plus 1x, negative 5x, and 1 times negative 3 is negative 3. So that works out. Let's take a look at a second example, which is not quite as easy. Okay, so we're going to take a look at 4x squared plus 9x minus 9. Now we see here that there's more than one possible combination that'll give us 4x squared, and there's more than one possible combination that's going to give us negative 9 here. So what you do is you just go one by one, test them out. So let's say for 4 I pick 2 and 2, and then for 9 let me pick 3 and 3. Now again, we have two possible ways of multiplying them. Okay. We notice that in this case here, they're actually equivalent. So let's check it out. 2 times 3 is 6, 2 times 3 is 6, or 2 times 3 is 6, 2 times 3 is 6. In this case here, ended up being the same thing. But with 6 and 6, there's no way to get to 9. So now I just have to try other possibilities. So let me change, instead of 2 and 2, let me take 4 and 1, and I'll keep the 3 and 3. I'll change that later if I need that. So we have this possible combination of multiplications, or this possible combination of multiplications. So if we try 4 times 3 is 12, 1 times 3 is 3, so 12 and 3, and that looks promising. Now again, because this is negative 9, one of these will have to be negative. So we notice that if we take positive 12 and negative 3, 12 minus 3 is equal to 9. We have exactly what we need for that middle term. So that means we know that we're going to use 4 and 1, so 4x and 1x. And here we're going to use 3 and 3. Okay? Let's make sure we get the sign correct now. We have 12 and 3. So since we need positive 9, we need positive 12 and negative 3 for that. Okay, let's check it out. 4x times x, 4x squared. 12x minus 3x, 9x, negative 3 times positive 3, negative 9. Now that works out. Now this, you might say, does seem like a long process, especially if I have to do it in several cases. And that would be correct. It could be long. Having said that, you'll notice that as you get better and better with this system, you don't actually have to even write this out. You just start getting adept at being able to consider all the different multiplications in your head. The other thing is that this really works when the numbers are fairly nice. 4 and 9, 2 and 3, nice numbers. If I had 64 and 128, I might not try to do this by trial and error. There's just too many factors to consider. So for now, I would like you to give this way a go. And if you find yourself having too much difficulty, then I will show you an alternate algorithmic method.